project for deep learning where I'll talk about text recognition in motor plates for predictive maintenance. What is predictive maintenance? It's designed to help determine condition of equipment in order to estimate when maintenance should be performed. And what is it for? It's for smart replacement of machine, recover revenue, asset availability, lower the risk of any potential failure, and it's also used for Internet of Things. It's an application for it. So the company I work for does online predictive maintenance where the sensor sends the data to the cloud, the vibration data, and the cloud, the specialists will analyze this data. And this is the spectrum that they receive to analyze. So what is my project? So in order to generate a more accurate analysis, it's very important to know about the motor RPM, its rolling bearing manufacturer, frequency, and power. Why? Because the failure frequency formula is given as a function of the rotation, the nominal diameter of the rolling bearing, the contact angle, and the number of rolling elements. And the RPM is also very important, frequency, mainly because of the electrical, it could be an electrical fault, and power. So this is an example of my data. It can also be as bad as this one. So what was my approach? I tried 3 different deep learning algorithms, models, Transformer, Keras, and Google Vision. Keras was an out-of-box library that I found. It was very useful, it's free, but it did not give me the results I was expecting. So as you can see here, it's not very organized. I even tried to search for the nearest value for each word that I wanted. As you can see, like I was searching for hertz and for the rolling bearing number, for the RPM, but it was not as good. So Google Vision showed me much better results. Here I have some brief description of what it's Google Vision. And here you can see, even with the image tilted, Google Vision got me some great results. The data is much more organized here. As you can see, the number is right by what I needed it to be, the results for each one. Finally, the transformer. As you can see, the transformer here, it has the architecture of an encoder, a decoder, and attention. So what I was planning on doing would be to ingest my pictures, my data, and decode it into text. And as the attention, I would use the keywords that I wanted it to focus on. Unfortunately, it didn't work. I did write the text, the whole code for the transformer. And here is the code that I wrote for transformer. As you can see, it's ready to use. I just can't train it because I don't have what's written in the images. So my challenges for this project was collecting the data because the data stays in the company's database. So I needed to get a request to actually get that data. Also understanding the data, since it's very new for me, this vibration analysis and predictive maintenance, I needed to request a lot of information from our specialists to understand what I'm actually doing, why I'm gathering this data. So this is another challenge for me. The actual data was a challenge because, as you saw, a lot of the images were very poorly taken because they were all taken by humans. They can be blurry, they can be even the plates can be rusted because the engines or the motors can stay anywhere. And after that, of course, learning to work with different types of technologies and libraries, it's always a challenge to learn something and how to use it, and that was one of my challenges. What are the next steps that I plan on doing from here? Maybe write a better algorithm to select the value near the words of interest. So maybe actually write a CSV file perfectly with the values and what the keyword goes with it, which keyword goes with it. And then I was thinking maybe load my transformer model with that CSV file that I created from the Google Vision API. And that way I could train my transformer and actually get my code to work. So I thank you very much for paying attention to my presentation.